Hi, let's practice the Ford Fulkerson method, which is also, I call it the zero cut method, to calculate max flow through a network or a gallery here. The first thing you can do is actually place alphabets next to each one of these vertices. And then this is also called the top-down method. You should basically go along each path. For example, if along E, A, B, C, the smallest value on that path is 24, and subtract that value from every value on that path, and this gives you 14. Now it's called top down simply because you just can't jump edges. You can't go to a top edge and then go down to the bottom edge and follow paths along it. So, and if you look at what we have done now, EA has become 0, so you can't actually move along that path anymore, and so you should now go to the maybe any path that takes off from ED. Now ED can go to A. Remember, this is a top-down method, so always go back to the top and come down. So we take the path E, D, A, B, C. Now if you look along that path, 4 is the smallest value. So you will subtract 4, that becomes 31, that becomes 6, and that's 0, and that becomes 10. The next path you take is EDC, and the smallest value along that path, it's a comparison between 31 and 30, is 30. So subtract that from every value on that path, and that's 1. And then the next path that you can possibly take is EDMNC. And if you look along that, 1 is the smallest value. So that one becomes 0, and that becomes 15. That's 19. That becomes 43. So now obviously you can't go along ED because ED has become 0. So now let's come along the edge EM. And the MD is, the arrow is in the opposite direction, so you can't go along MD. You can go along ND, but then you come to DC, which is 0, so you can't go along that path. So we now take EMNC as the last path. And the smallest value along that is 19. So that becomes 0. 28 take away 19 is 9. And 43 take away 19 is 24. And now there is no more paths that we can move people through, because on every path there is a 0 that obstructs it. And when we add, it gives you 78 as the max flow. Now, if you look at the position of the zeros, that's here. Oh, sorry, that is 0. We can find another 0 here. We can find a 0 here, a 0 here, a 0 here. The position of the zeros actually can help you find the minimum cut. So if we just look along EA and go down the zeros from that end, that is 24 plus 35, which is 59, and 59 plus 20 is obviously not 78. So that the position of those zeros is not going to help. Whereas if you went through these zeros, that's 28. You won't include 18 because it's a backward flow, and 30, that's 58, and 58 plus, you won't include 22 because it's a backward flow, and 20 gives you 78. So this is the minimum cut, which represents the max flow through the network. Now you should know that the max flow through the network can only be equal to this cut or less than it. Okay, so clearly this cut is not max flow because it's not equal to 78. So we have identified this particular one to be the minimum cut, which represents the max flow. Thank you.